and welcome to Mambel Technology Group. Thank you for joining us today again. Today we're going to continue from where we stopped last time. In our previous video, I showed you how to set up high availability and disaster recovery solution. So this diagram here is just a quick recap on what we did in our last video. And today we're going to do practical hands-on setting up HADR between two different sites or two different geographical locations, the primary and the secondary data center. So as you can see here, we have our window failover cluster here that is set up, and we have always on availability group set up between these two VMs, node 1 and node 2. And this all happens here in the primary data center. And this setup here is basically our high availability solution. Always on is one of the high availability solutions that is provided by Microsoft. And in this video, we're using SQL Server 2019 Enterprise Edition for our setup. If you're watching this video for your first time, I would suggest to go back on our YouTube links and watch our videos on how to set up prepare your environment before you could create always on availability group. In the previous videos, I showed you guys how to set up a VM, how to build a VM, add it to a network, add it to a domain, and subsequently how to create always on availability group. So if you're here for the first time, I would suggest to click on the link in the description to watch our previous video for a better understanding. Now, I assume that everybody watching this has an understanding or has a knowledge of what always on availability group is. It's basically a group of databases that will fail over from the primary node to the secondary node in an event of a disaster or a failover that can be triggered by a user. So in here we have our node 1, which is our primary instance of SQL Server. So the VM here is node 1, and we have these 4 databases that are part of the availability group. And the setup here is in synchronous commit mode, which means we have little or no data loss, and we prioritize data over latency, right? So that is how it is set up here. And we have our listener here, which is a computer object with an IP address and a port number that routes connection from our user Lucy. So if Lucy is trying to make a connection, and always on availability group through the listener will always point the connection to whichever node in the setup is the primary. So from this topology here, node 1 is the primary. And in the last video, I indicated that this red arrow right here shows our read-only routing if we desired to set that up, which is kind of sort of a balancing load between the primary and the secondary replica in such a way that the primary replica does not overwork out or does not overdo the work while this one is isolated. And if a failover does not occur and read and write operation happens only on the primary, then this secondary node 2 here will just be a static inactive replica or a passive node, if you can call it that way. But for the purpose of balancing the workload, we can reroute our read-only connections to the secondary, and these can only be achieved if you set up read-only routing, which we will see in our subsequent videos. And in the connection string, you have to specify the intent of the application. So the red circle here indicates one of our most critical databases that we want to use for HADR, for always on and lock shipping. So our HADR solution here is always on, that is set up in the primary data center, and a database, which is the most critical database in our setup, is going to be lock shipped in a secondary data center. This database contains information that has to be up and running 24/7. It contains critical information that should not be lost. So the concept of HADR is basically to have data redundancy in such a way that if we have a geographical failure in this primary region or the primary data center, and everything goes down node 1 and node 2, we can always rely on node 3 to bring up our database, and our connection now will be remapped to this new environment. So this is basically to make sure that in case of an outage, we can always have our data and have somewhere to recover. So this is just like a backup plan, and this is implemented by most companies to have redundant data. Now, there are many other ways or many other technologies that can be used to achieve the same result, but for the purpose of this video, we decided to leverage always on availability group plus lock shipping. And you can see from the diagram, node 3 is in a separate data center, which means it communicates with the primary data center through this database. Now, somebody is going to ask me, what happens to the other databases? This is just an illustration of this one database. You can as well leverage all the other databases depending on how critical they are and how the business relies on these databases. But for the purpose of our demonstration, this one database, I use it to show you that you can leverage this with your other databases to have an HADR solution. How this works, how it is set up, how you make sure that your data is constantly being copied from this primary data center to the secondary data center, we will see that in the demo video hands-on, because there are setups that you have to make sure that your data is being transferred to the secondary data center at every given point in time. So let's switch here to our demo session and see how it works. I hope everybody gets it, and I hope you understand all of this part. So when we do the demo, you will get more understanding. Okay, so now that we are on our dashboard, let's first of all make sure that everything here is just good and fine. So as you can see, this is my node 1 and this is node 2. Let's check the state of availability group. First thing here, you want to make sure to check your availability group. This is a primary, and in here our availability database is ServentRworks 2019. So the first thing, let me check the health of the availability group by going to the dashboard. You can see that my availability group is healthy, and the availability mode is synchronous commit mode with automatic failover, and there is no data loss. So the first thing to set up high availability and disaster recovery using always on lock shipping is to first of all check your availability group properties to check where your backup is running. So in this setting, it is recommended to allow your backup to always be running on the primary, which means that at every given point in time, even if there is a failover, your backup will still be running. And if you take a look on our diagram that I showed here on this topology, we want to make sure that we connect to the availability group using the listener and use our backup preference to be the primary. Why? If we decide to use a particular instance, say node 1 as our backup server, and we set up lock shipping between these three nodes here, if there is a failover and this node 1 fails over to node 2 and then node 2 becomes the new primary, the lock shipping job will be failing because node 1 here, excuse me, node 1 here will not be able to talk to node 3 anymore, and the new primary, which is supposed to be shipping the logs, does not have the backup job because it is not it was not set up for the backup. That is why we will choose the backup setting to be the primary at the primary, which means irrespective whether node 1 or node 2 is the primary, the backup job will still be running. And the log shipping has three jobs, right? Backup, copy, and restore. The backup jobs run on the primary data center. The copy and the restore jobs is going to happen on node 3. So let's go back to our, so this is our server here. As you can see up here, this is node 1, and the backup preference here is primary. So at this point, we are good. Okay, let's go ahead and set our log shipping. To do that, look for the database, which is Adventure Work, that is participating in Always On. Right click on it. You can go on task and ship transaction logs. This is to set up our log shipping. And if you're doing this for the first time, you will notice that here log shipping is not enabled. So the first step in log shipping is to enable this as the primary database in the log shipping configuration. And yes, Adventure Work 2019 is going to be our primary database in this setup. So I'll click here, and just like I said again, that log shipping has three jobs. The first job is the backup job, the second job is the copy job, and the third job is the restore. And we will see all those jobs in this setting. So let's set up our backup here. It says network path to the backup folder. So here you have to provide if the backup happens on the primary or the secondary, depending on which one is running the backup job at that point in time. Where do you want the backup copies to be stored? This is important to note that you don't have to store the backup copy as a local copy, which means you don't have to go on node 1 and store the backup in the backup files on node 1, and the same for node 2. Right, you need to have a shared folder that both node 1, node 2 can be writing to, and as well as node 3, which is receiving the logship database, should be able to go in that folder and pick all the backup files to be restored to node 3. So here we need to provide a shared folder, and for that, in our last class, we used the file share that we created in our domain controller. And on this file share, we have to make sure that every instance that is participating in this topology must have access to read or write data on this file share. And to do that, we can verify by going in the properties under security. And you can see that node 1 has full access, node 2 has full access, and node 3 should be here as full access. One other thing that you should pay attention to is the service account that is used to do the job. So every service account that you're using also needs to have access on this shared folder to be able to copy or read data from this folder. Right. So since that is done, let's actually copy the file path again. So to copy it, go to properties and then go to sharing and copy this. This is the file path we're going to use to set up our backup. So every backup should be coming to this location, right? And this is really good because you can always go through the writings here to have more understanding of what it's doing. Now, it says delete files. This is basically important, especially for capacity planning, because definitely storage is a limited resource and we don't want to have a lot of files kept pile up in our storage. So we want to be able to make sure that we delete files that are older than, depending on the number of times you want to delete, minute, days, hours. We can say days, delete files that are older than 3 days, for example. And then this is an alert that you can set up if a backup does not occur, depending on what is the frequency of your backup. You can set this accordingly. So I would say a minute, if my backup does not occur after maybe 15 minutes, send an alert. What is the job name here? The backup name here is log shipping backup. I'm just going to leave this default name, right? I will just leave this default name. That is it. Remember, when you're setting up log shipping, it creates 3 jobs. One job is the backup job, and the other 2 jobs is the copy and the restore job that runs on the secondary server. So I will leave the default names here, and I will change the schedule later. So let me just leave it like this for now and say okay. Now our backup setting is done. secondary server instance of databases, we need to add a secondary server. If this is a database that you want to replicate to multiple servers or to multiple other secondary servers, for the case of redundancy or depending on the critical nature of the applications running on the database, then you can add more than one server here. But for the purpose of this video, we're just going to use one secondary server. So click on add here. And at this point, this is where you have to add node 3, because node 3 is our log sheet server, or the secondary server where we want to send the data to in the secondary data center. You can see here our secondary server is going to be node 3, which is in the secondary data center away from the primary data center. All right. So node 3 here, I'm just going to provide the server name. Click on connect and provide the server name here. I think it's node 3. Node 3. Connect. And here we are connected on our secondary servers. The database name in the secondary location, that is the name we want to have there. You can always modify this name to give a different name if you want to, but I'm just going to leave it default as a primary. And yes, so what are the restore operations? But before we get here, you need to make sure that you set up the restore operation. So here, what is it saying here? In log shipping, just like always on, you have to initialize the secondary server or a secondary database. So you have here, you have two options, or maybe three options. The first thing you can do before going through this setting, you can take a full backup of your database and restore it on the secondary server and leave it in restoring mode. That is initializing the log shipping process, just like we do with always on. Or here, SQL Server is saying that it can generate a backup for you if you don't already have a backup, and also restore the backup for you on the secondary server, which is our case here. If we go on node 3 has no database on it, right? You can see we don't have no database on node 3, so we can use this technology to SQL Server, for SQL Server to take a backup for us, copy the backup over to node 3 and restore it. And for this, the SQL Server agent that is taking the backup, and the SQL Server agent or service account that is taking the backup, that is used in taking the backup and used in doing the restore, has to have permissions on the required folders where it needs to copy the backup file to and to read the backup file from to be able to restore. So since I don't have no database in my remote server yet, or my disaster recovery server, I will go with this first option. You also have the possibility to go with this second option, which means you have already taken the backup and it is saved somewhere in the shared folder or in a location where the disaster recovery server or the logship server can just pick the backup there and restore. And then this last option where you can say, okay, no, I already restored my backup there, or my backup has already been, my database has already been initialized. So I will go with this first option and say restore option. First, it is asking you for the files. Remember, since SQL Server will be doing a full backup and restore for you, you need to provide the file location of your data files and the log files of the server where the database is being restored to. And in this case, it is in node 3. So you need to provide the backup file and the data file and the log file for node 3. So let's go over to node 3 here. And I will go in my files here. For my data, go into the data drive, and this is where all my data files will be stored. So I will copy this path here and provide it here. Now I need to also provide a path for my log. So the same operation, go to node 3 and look for the log drive. The log drive is right here. and I'll copy this file, this folder here, and make sure there is permission on those folders before you can proceed. And I'll provide it here. Right. So SQL Server will take backup on the primary here of Adventure 2019. It will back it up for me, save it in the network location. Then another agent will come and pick this backup file and restore it on node 3. Say OK. Next is our copy files. Right. Destination folder for copied files. Since the backup is coming from a different location, which is our shared folder, where is our file after the backup is taken? If the secondary or node 3 wants to restore that backup file, where is it going to copy it and keep it before it's being restored? So you need to provide the backup file here, and I will still go on the node 3 and look for my backup directory. We are here in node 3. This is my backup directory, and I will copy this and provide it here. So whenever a file will be copied from the shared, from the network shared, it will save the file here, right? Once it's copied from DC, which is my network share, you will save it here on node 3. Then the restore operation can go from there. Delete copied files after, you can say 3 days. Let me still put this one into 3 days. Once my files are copied after 3 days, you can delete it. And this is the job name, right? Log shipping copy node 1. So it's basically telling you that this is a log shipping copy that is coming from node 1. And I think this name is not too bad. It's a good name because it gives you an understanding of what it's doing here. It's a log shipping copy, and this copy is coming from node 1, and it's a copy of AdventureWork 2019 database. So I'm still going to go with the default name here. Then the restore of the transaction log. This is very important here, and everybody needs to pay attention to this. So you have two options when you're restoring your database in the disaster recovery environment. You have the no recovery mode and you have the standby mode. So the no recovery mode means it's not even accessible. The standby mode means you can read from that database in the DR environment. You have read permission, you can read data from it, but the no recovery mode means you cannot even read. So since we want to be able to read data from it and probably to compare data sometimes or maybe for other purposes, then we will go with the standby mode. And another thing to pay attention here is to disconnect users, because during the backup, during the restore operation, if users are still connected on that database, the backup or the restore operation might fail. So it's always good to check this box to kick out every user that is connected on that database at the time where the restore is done. So if you check this box, every user will be connected for a few seconds while the restore takes place, and the connection will be reestablished once the restore is done. And okay, another thing here is delaying the restore for at least a couple of minutes. It's always good to delay the restore maybe for 2 minutes, just so that because of the distance, there is a considerable distance between the primary and the secondary data center, and the copy operations over the network due to network bandwidth or network latency, and the throughput might delay the backup copy. So you want to make sure that you also delay or restore to give that time so that your backup files can be properly copied over before the restore takes place, and also alert if the restore doesn't happen after 15 minutes. Great. At this point, we should be just good, and if everything is great, you can just click OK. Another thing to pay attention to here is the monitor. So you can also use another instance or another node to monitor your log shipping operation. It's just going to be there to look if the lock shipping is running just fine and to notify you, or just like the quorum works in always in availability group. The monitor is there just to monitor, right? But I don't need any monitor right now. And let me script out the configuration. I script it out to a new core window, and I'll tell you why later down the line. So click on OK. Once you click on OK and everything is good, it's going to create all the jobs and everything will work just fine. As you can see, it took a backup of the primary database for us and it restored a backup to node 3. And you can see the steps here says everything the status succeeded. I showed you earlier that we don't have no adventure work on node 3, but what this did right here, it backed up the database for us. It copied the backup files and it restored it on node 3, and it's saving it as a secondary. So let's go and see on node 3 if we actually have a new database that is just been created. This is our node 3. Let's refresh databases, and you can see our adventure work database is right here, and you can see that it is in standby mode, just like I indicated earlier, and it's read only. It means it's in standby, but you have permission, you can read this. If we had chosen recovery, then you could not even read anything from here. So our setup is good, but there is one more thing that is left to be done. The setup is just between node 1 and node 3. Right, let me connect my node 3 here and make sure I have everything in place. Okay, so now everything is right here. You can see this is my logship database, and for now it is running between node 1. It is running between node 1 and node 3, which is okay. So what I will do here, and there is something that I forgot to mention at the beginning of this. It is always recommended, it's good practice before you do these settings, make sure you connect to the server using the listener. That is something that I was going to mention at the beginning, but I forgot to do that. Always connect using the listener while you're doing this so that you're sure of doing or writing on the primary at every given point in time. It's always very important to know that you're connected through the listener. And this is what I scripted out. This is the entire lock shipping process that I scripted out. It's important. Why? Because the first part of the lock shipping here is performing a backup job. And that backup job as of now only exists on node 1. So let's connect on node 1 and verify. You can expand your job here. You can see that we have a lock shipping job here that is on node 1. What if node 1 fails over to node 2? What is going to happen? This job is not going to fail over. Remember, jobs are created at the level of the MSDB, not at the level of the databases that are part of the availability group. So if there is a failover, your lock shipping will fail. So that is why you have to create this same job on the secondary server, the backup job, right? And if I connect on my node 3, where we send our logship database, you will see that we have two jobs there. We have the copy job and we have the restore job, just as you can see here. We have this copy job that copies the files from the shared folder or from the shared location to the backup folders of node 3. And then we have the last job, which is the restore job. So it's very important to understand all these steps, right? So at this point, we have to copy this first part. Script to be run at the primary. So this first part of the script is what has to be run at the primary, right? DCC script to be run at the primary, which is node 1, right? And then this one is a script to be run on the secondary. So we are more interested in the first part of this script, which is going to be doing our backup job for us. That is what we need to copy and run on the node 2, which is part of the availability group, so that if there is a failover, node 2 can continue to do the backup, because we have set our backup to be running only on the primary. which means if there's a failover from node 1 to node 2 becomes the primary server and node 1 becomes a secondary server. And since the backup is set up to run only on the primary, node 1 will not be able to execute the backup job. The backup will start running on node 2. And if we don't create this job on node 2, then the lock shipping will be failing. I hope you get this point. All right. So now that we have our lock shipping set up on the primary, and we can see that our database is synchronized with the secondary here, let's do one more thing here. And what we're going to do is to connect using the listener. Let's connect using our listener here, which is this one. And if you look at the availability group here, this is our primary. And from availability replicas, it shows that node 1 is a primary. So let's actually trigger a failover. We're failing over because we want to make sure that we create the backup job on the secondary replica, which is node 2, right? And because we said that the backup can only run on the primary node, so we have to fail over and make sure that our backup runs on the primary. Now we are here. We just had a failover. If you check the replicas now, node 2 should be the primary. Now, at this point, we are sitting on the primary. Let me just change connection to make sure that I'm connected. Okay, great. So the last step to run is to run this first part of the script, right? First part here, which says this should be run at the primary. So we already ran it on node 1. We just have to run it here on node 2. Since we're connecting using the listener, we know that node 2 is definitely the primary. And once we run that, it will create the backup job on node 2, and everything else should be good from there. So select this and run it. It is successful. Now, if you connect to node 2, you should be able to see the job created, right? You should be able to see the job created here on the node 2, right? You see, create a backup job and alert and every other thing. At this point, even if we fail over from between node 1 and node 2, our backup will still be running and our node 3 will still be fully synchronized. But there is one more thing to do here. If there is a failover from node 1 to node 2, the jobs are enabled on both servers, so the job will keep failing, and you don't want to be receiving a lot of alerts that my jobs are failing, your job or your backup job is failing, because maybe the other one is trying, and the alert is being sent out that the backups are not running whenever it becomes the secondary. So at this point, it is always good to add a job step. It's good to add a job step on the backup on both node 1 and node 2 to make sure that it goes in, it checks first which node is the primary, and if it is the primary, it triggers the job, the backup job. If it is not the primary, it simply stops the job, which is very important. So if you go in our SQL Server agent here, on node 1, you look at the backup job. If you look at the properties and you look at the steps, it has just this step, and the same thing on node 2. So let's add another step here. And basically what the step will be doing is checking the availability group role, and it's checking which server is the primary. And if it is a primary, it will be running the job. If it's not the primary, the job will stop. And that is very important. So right now, let's add the role. Right, so we're back here. And now this is a script to check the availability group role. And as you can see from the script here, what it's basically doing is going in there and it's checking the availability group role. And our availability group is demo AG. So you can see our availability group is demo AG. And it's going there to check if it's a primary. And it says begin print start. If this is a primary, then it needs to do something. It needs to run the backup, right? It will start the backup job. else it stops the job, and the job name is log shipping backup 2019 that you can find under our SQL Server agent. This is the backup here. So this script, which we have to add this script in the first step on both nodes. So I'll copy the script and I'll go on this job properties. It has just one step, so let me add a new step here, and I'll paste it here, and I'll call this step name AG role check. So basically what it's doing is going in there to check the role. Click on OK, and you have to pay attention here. Once you add this role, by default it's going to be the second role, but what we want this role to be the first role to run, so that when SQL Server runs this one and it finds out that this is a primary replica, it will go ahead and do the log shipping backup. If not, it will just stop the job. And you can see down here it says start step. Here is starting at step 1, and step 1 here is log shipping. You cannot run the backup before checking the role, so we need to move. You can just click here and then highlight AD check role and then move it up. At this point, it is at the first step here, and also now set the step, start step 1, which is AG role check, and click on OK. Do the same thing for node 2. Let's go on node 2 and look at the job. Let's add the step. At this point, we have one step. Let's add a new step and paste the same in here. All right. Let's still call it AG role check. And it's basically going to be doing the same thing, and let's do the change as we did on the other side and start on step 1 and click on OK. Very good. At this point, we are good. Whatever, our job should be running smoothly now. One thing we didn't change was the schedule. So let me check on the schedule of those jobs and make sure that I synchronize the schedule so that we can have some demo and see how it's running. So let's look at the backup schedule here and edit. What time is it here? So on my VM here on node 1, it's 9:51 p.m. So we can say our backup, we want our backup to be running every 2 minutes. Let's just leave it every 2 minutes and starting at 9:52. Great. That is it on 1. Let's do the same thing on node 2. Let's look at the schedule here and change the schedule. We're just doing this because we want to watch and see how it runs every 2 minutes, and start at 9. Let me look at node 3. What time is it on node 3? On node 3 is 9:52. Okay, let's see. 52, same thing. So it will be running every 2 minutes, our backups. So the first thing I want to check here, let me check our backup now here. View the history. So it ran at 9:45. Definitely there should be a new backup that should have run at 9:52. Let me verify and make sure that we did the proper changes. Okay, so let's verify the job execution. But before you verify, just check which node is a primary at this point in time. Okay, you can see that node 1 is a secondary, and node 1 is a secondary right now, and the primary replica is node 2. So if you check the same thing on node 2, you will see that 2 is the primary. Now, when we were setting our backup, we said the backup can only run on the primary, and this job step is there to verify the backup. This is the first step in the job, is checking which node is the primary. If you are the primary, then go ahead and take the backup. If you are not the primary, I'm just stopping the job at step 1, so it will not even move to step 2 to take a backup. Let's verify that. Node 1, which is a secondary, should have the jobs stop. Right, so look at the backup job and view history. Exactly, as you can see here, at 9:54 it stopped the job. And if you expand this, you can highlight here and look at this. Right, what does it say? Let's expand this. The step was cancelled. It was stopped as a result of a stop job request. Why was it stopped? Node 2, node 1 is the secondary, and the backup preference is running only on the primary. If you want to confirm that, go on the availability group, right click and go to properties and check on the backup. You will see that the backup is highlighted here. It runs only on the primary. So if it's not the primary, step 1 of the job, this step will stop the job. Let's go on the secondary, on the primary, which is node 2, and verify. Everything should actually be running fine. The backup should just be succeeding because this is the primary and it's authorized to be running the backup. So let's look at the job right here and view history. As you can see, the job is running successfully. We had a run on 9:45. That is before we changed the schedule. And after we change the schedule, you can see it's running every 2 minutes, 9:54, 9:56. And every step is running both step 1. The first step is to check the availability group role, right? Which once it succeeds, it says, okay, I checked the role. This is the primary. Then I can go ahead and run the backup. And you can see that it's succeeding. If we fail over, at this point, node 2, which is the actual primary, will become the secondary, and all this succeeding job will stop. It will not execute. So let's do a proof of concept. Let's go on the primary here, on the secondary. Let's do a failover. And pay attention, node 1 is the secondary now. Once we fail over, it becomes the primary, and it will start running the backup job. Fail over. Okay. It cannot fail over. Let me see. There's probably a backup running. All right. So I don't know why we're getting this error, but I think this is something that I've seen in the past, and it's telling us to, run using the master, but we are using the GUI. How do you tell the GUI that I want you to use master to connect to my database, right? Because when we're trying to fail over, that should be done through the master. Now, using the transact SQL or the script, this is possible, but how do you do that with the GUI? First of all, diagnosis. How do we find out what is our default database our instances are connecting to? Let's do this. So let's try to connect on the primary node, and you have this option here. Let's check this option and see which is our default database we are connecting to. Adventure work. Now you see this is the error here. We have to change this one to the master database because we should be connecting to the master by default. You cannot perform a failover where you're pointing here. And I think this is what is telling us behind the scene, right? So let's point it to master and say, okay, our default database is master, right? Connect. So if we do that, we're connected. Here, this is node 2. Let's see what node 2 has as the default. It says default, and whichever is default, I don't know, just to be sure, let's make our default to be master. At this point, let's try to fail over again and see. It's always good to look up these error messages if you have one. Let's try to fail over again. If it happens, then we will go and troubleshoot more. So let me cancel this, and our availability group is here. This is a secondary, so we want this one to become our new primary. Let's fail over and see. We are getting the same error, so definitely it is something else. We might definitely need to run a script to get this done. So as you can see, our connection, our failover is successful. So what I had to do was just, to disconnect these sessions that were already running and connect the new sessions, pointing our default database to the master. So that was everything that you need to do. So sometimes we get these errors and we need to troubleshoot. I don't know. I don't have any explanation of how the default change from the database change from the default to AdventureWorks. I don't have no explanation on that. But what I know is that I had to change the default database from AdventureWorks to master, and the failover is successful. And at this point, you can see that node 1 is our new primary. And since node 1 is our new primary, then definitely our backup jobs should be succeeding on node 1 now and failing on node 2. So let's wait for the next run. The next run is in a 2 minute. That should be 10:10. We should have a successful run here. And on our new secondary, which was the previous primary, we should start having fail jobs here. Not failed jobs, but the jobs are going to be stopped by the first job step, which requires a stop. So let me check this. You see, now it is 10:10 p.m. At this point, the job just stopped because this is no longer the primary. When it was primary, the job will succeed all along the way. But now that it is secondary, the jobs will start stopping. It will not run anymore. It will stop at step 1. It will not proceed to the next step. Now let's go back to the primary and make sure that we had a successful run. View history. Exactly. And you can see at the same time at 10:10, the node 1, which is a new primary now, has its job running successfully. So the backup jobs now are running here successfully, and they're stopping on node 2. I hope this video was informative enough, and I hope you learned a lot here. And here, this marks the end of this session of our video, which we have seen that we were able to set up a high availability, a combination of a high availability and disaster recovery solution between two data centers. On the primary data center, we have always on availability group set up with synchronous commit mode. And in the secondary data center, we have node 3, which is a standalone database, which is configured with lock shipping. So lock shipping between the primary data center and the secondary data center. And with this, if the primary data center goes down, our critical database, which is represented with a red color, can always be online, can be brought online on node 3, and we can now reroute all connection strings or applications to be reading from this critical database. This is a mechanism that is put in place by Microsoft to help mitigate data loss, especially when there is a disaster. And this helps to keep our delicate or kind of critical application or data to constantly be available. And again, we could set 3 or 4 different replicas here where the data could be replicated to, and that will still work as well. And we saw that we had to make sure that we are running our backups on the primary node. That is why we had to create the backup jobs on both VMs that are participating in the availability group. So definitely if we had 6 replicas here, we will create the backup job on all 6 replicas and just add the job step to verify the availability group role and only run it when it is a primary role. I hope this was a good video. In our next session, we'll be talking about other new topics. And continue to like our channel, continue to subscribe and click the notification bell to get notified each time we upload a new video. Thank you for following Mambet Technology Group.